Well, I hope everybody's keeping well and things are going well for you individually. And today we're going to, very exciting, complete our final lesson in Chapter 6. And that lesson will be on something called molecular formula. If you remember our previous video, I talked about the empirical formula being the simplest formula in a compound, which we can figure out from percent composition data. And I'm sure you're all experts at that by now. We have one little step to go, which is not that difficult, to be honest, and that is something called the molecular formula. And the molecular formula really is the same as the actual formula. So when you look at the formula of any compound, that indeed is the molecular formula. The empirical formula, if you remember, is the simplest ratio, mole ratio, I should say, of elements in a compound. So let's take a look at a previous example, if you think back to where we were before. By the way, this is section 6.9 in your textbook, and that's on page 296 to 300. I will talk about molecular formula and refer to it as MF, just like I referred to as empirical formula as EF. So if we look back at glucose, which of course is blood sugar, it's also found in a lot of foods, sugary foods I should say. The empirical formula, remember, is CH2O, and that would have a molar mass of 30 grams per mole. The actual formula, which you learned long ago likely, is C6H12O6. Well, it turns out that molar mass, if you go through all the elements, ends up being 180 grams per mole. And it's pretty quick to see that this number is 6 times as big as this number. So we can actually figure out the molecular formula from the empirical formula if we can find out what X is. And so the molecular formula mass is always going to be equal to the empirical formula mass times some variable X. And clearly in this case you can see that X is 6. So that's really what we're going to do today. That's the simplistic look at it. Now, let's take a look at another compound which is found in your body when you work out a lot, and that's called lactic acid. This is the material that builds up in your muscles when you hit the wall, when you have an oxygen debt, and usually it feels like a slow burn in your muscles. The only way to get rid of it is actually to slow down or stop working out to allow the oxygen to come back in your body. But let's not worry about the biology of it all. Chemically, we know that it consists of 40% carbon, 6.7% hydrogen, and 53.29% oxygen. By analysis, we know the molar mass is 90, and the question is, determine the empirical formula and the molecular formula. This brings together both concepts of EF and MF. So let's quickly go through it. Remember your table? We have these 3 elements here, and we're going to assume 100 grams of material. So let's just go right to the mass level. So we end up having 40.0 grams of carbon. We have 6.71 grams of hydrogen and 53.29 grams of oxygen. So this should be old news for you. Percent to mass, mass to mole. Next step, find our moles. We know that moles equals grams over molar mass, which is 40 over 12.01. And I'm going to use some decimals here in order to reduce the chances of a round-off error when we get to our final answer. Likewise, down below, for hydrogen, we have 6.71 over 1.01. And for the oxygen, we have 53.29 divided by 16. Now, if we quickly go through our math, we can easily see here that this number ends up being about 3.3 repeating. 6.71 over 1.01 is about 6.64 moles. And the bottom number for the oxygen ends up being about the same as the carbon. You can check on your own, it ends up being about 3.33 moles. Of course, these are all moles, and it isn't too hard to see what's happening here. Clearly, the carbon and oxygen represent half as many moles as the hydrogen, so if we multiply to a whole, we get a ratio of 1 to 2 to 1. So the EF is quite easy to get, right? Our empirical formula is simply going to be CH2O. So now we have done the hard part, really. Let's now look at the molecular formula. Well, remember our little equation over here. If we know the empirical formula and we know the molar mass, we can find X very easily and thereby figure out the formula. So let's go ahead and do it. If you look at our molecular formula, you're given the molar mass as 90, and this is important. So our molecular formula mass is equal to X times the empirical formula. So we have this side is 90, and X we got to find. And if you look at the EF here, carbon is 12, 2 hydrogens adds up to 14, and 16 gives us a molar mass of 30. So mental math, again, you can do this in your head. I have confidence in all of you. So when you look at it, you can see that X is equal to 90 over 30, and of course that ends up being 3. So when all is said and done, we end up with the answer, which is the molecular formula. The actual formula for lactic acid ends up being C3H6O3. And that's as easy as it is. All we have to do is set up our table, use your rhyme, percent to mass, mass to mole, divide by small, multiply to a whole. Again, this time we didn't have to multiply to a whole because the numbers are even, and plug in your little handy dandy empirical molecular formula equation to find X. Hopefully this helped. Short lesson, but certainly gives you the tools you need to figure these kinds of problems out. Next, I'm going to run through one question in the textbook, which is a little bit different than this, but I think will help you build some confidence with molecular formulas.